Okay, so the homemade diesel generator is done, basically. I haven't painted the frame yet because I haven't decided if I want to put wheels on it. Right now it's just sitting on some rubber isolators. It's exceeded my expectations. There's been some changes since I talked about my plans to make a generator during the review of the engine. If you haven't seen the review of the engine and you just want to see that, there's a link provided above right now. The first change is that I mashed my own fuel tank. For all my talk about the UPS guy, I had a mishap of my own and I crushed my fuel tank. I ordered a new one on eBay and it came very quickly, so parts are available. The other change is I had talked about running this at 2400 RPM and using a belt drive up to 3600 RPM for the generator head. And right after I did that video, I did some math and decided I want the full horsepower and RPM out of this engine. And so I decided to go with a Lovejoy direct drive coupling. That comes with its own set of challenges, which I'll talk about at the end of the video for folks that are interested in building their own generator. But I'm going to try and get this running and pull some amperage off it real quick if that's all you really want to see. I'm going to do a 360 here. Sorry about the angle of the sun. I'm trying to get this done in early morning Florida before that sun gets up too high. And before I fire it up, I'm just going to talk about a couple of things here. When it's running, I'm going to have a Hertz meter that hopefully the camera will pick up. If it doesn't pick up the digital Hertz readout, then I'll post some captions to show you what's happening. The governor works superbly. When the engine's freewheeling, like any governor, the governor just kind of floats because it doesn't really know what it's supposed to be doing. I have it set to float in the high range. It'll float from like 60.2 Hertz to like 61.3 Hertz, which is totally in the acceptable range. And you're allowed to go like up to 61.5 down to 58.5 for the Hertz range. I'm not going to plug it into my house, but I have plugged into my house grid. I've run my refrigerator, ceiling fans, lights, and of course kicked on my water pump, and it performed flawlessly. If I plugged it into my house now, all you'd see is the generator running with a big yellow cord coming out of it. So instead, I'm going to get it fired up. I'm going to pull some heavy amperage off either side of the 110, 120, whatever you want to call it. I'm going to pull 10 amps off one side with my shop vac and 15 amps off the other side with my Harbor Freight chop saw, and trust me, that has a horrific surge. It flickers the lights in my house on street power. So that's a good replication of being plugged into the 220 grid of the house and running moderate amperage. What I'm going to do now is I'm going to move the camera back. I'm going to get it started. I'm going to warm it up at a low RPM. Then I'm going to move the camera in and bring it up to 3600. The Hertz meter really won't register until it gets up around that range, and then it'll flick on and hopefully you can read it. And then afterwards I'm going to talk about some of the trials and tribulations of this build. If you want to stick around if you're interested in building your own generator. let's talk about the build. For those that didn't watch the original video of the engine and hear all my plans, this is a 9 or 10 horsepower Chinese diesel. Bought it online. The generator head is a Winco 4800 watt, and they are coupled together, like I said, with a Lovejoy coupling. The challenges of that, let's just start in the middle, is that that's not a rubber U-joint. It's a coupling, and it has very, very, very tight tolerances. Lovejoy actually allows you 15 thousandths up or down or side to side. I can't imagine that. I think that would tear up the rubber insert or the bearings on either side in the engine or the generator head. Mine is set exactly. You know, with a straight edge across that, you can't even slide in a piece of tin foil in any direction. They allow you 1 degree, I think, of angular deviation, and I don't have that either. This is set dead on. And that's where the challenge came in, because they have to be, unlike belts, which give you a lot of tolerance, these have to be bolted to a common steel surface. The engine cannot vibrate independent or just tear that coupling up. So they both have to be bolted to a common steel surface with no rubber mounting. And without a milling machine to make that exact step, it was very difficult. It took a lot of work on a very flat steel table. The fuel consumption is still just negligible. Turn this off. I've got about 5-6 hours into this thing, you know, testing, running, doing different things, and fuel's about right there. I did top it off once. I put in about a 1/2 inch because I wanted to do some measuring before I mashed my tank. And it seems to consume about a 1/2 inch an hour. It's just amazing what little bit of fuel it consumes and what just great power it has. You might be asking, well, why isn't it sitting on wheels? Well, once these are bolted to that solid steel frame, you need some type of shock isolation. And right now, as I said before, it's just sitting on rubber mounts. If I were to use wheels for that shock isolation, they'd have to be pneumatic. And anybody with a wheelbarrow knows what I'll be dealing with every month, and that's pumping up my pneumatic wheels. Right now I just flip it up, slide the cart underneath it, and move it wherever I want. So I'm still undecided on whether to use wheels or just leave it like it is. I'm going to put on my new gas tank, and that's about all there is. If you got any questions, feel free to post them, and thanks for watching.